Determine the radius of convergence of the series from k equals 0 to infinity of 2 to the 2k times x to the 2k and write out a 6th-degree polynomial approximation of this series. To see for which values of x the series converges, we need to use the ratio test. To use the ratio test, we need to evaluate the limit as k approaches infinity of the absolute value of the a sub n plus 1 term over the a sub n term. If this limit is less than 1, then the series converges. Whenever the limit is greater than 1, the series diverges. And whenever the limit is equal to 1, the test is inconclusive. For this particular series, the limit as k approaches infinity of the absolute value of a sub n plus 1 over a sub n is equal to the limit as k approaches infinity of 2 to the 2 times k plus 1 times x to the 2 times k plus 1 all over 2 to the 2k times x to the 2k, which we can rewrite as the limit as k approaches infinity of the absolute value of 2 to the 2k plus 2, x to the 2k plus 2, over 2 to the 2k, x to the 2k. Simplifying by subtracting exponents, we get that this equals the limit as k approaches infinity of the absolute value of 2 to the 2 times x to the 2, which is really just the limit as k approaches infinity of 4x squared, which is 4 times the limit as k approaches infinity of x squared. We don't need the absolute values because everything is squared and therefore non-negative already. Now, to figure out the radius of convergence, we need to figure out what values of x would make 4 times the limit as k approaches infinity of x squared less than 1. In other words, for what values of x will the limit as k approaches infinity of x squared be less than 1/4? Since the limit is as k approaches infinity, x is not affected by the limit, so as far as the limit is concerned, x is a constant. So what we're really trying to figure out is when is x squared less than 1/4, which will happen anytime x is between -1/2 and 1/2. The interval -1/2 to 1/2 is not necessarily the interval of convergence, since we haven't checked to see whether the series converges or diverges at the endpoints when x equals plus or minus 1/2. But we don't need to know that to calculate the radius of convergence. The interval has length 1/2 minus -1/2 equals 1. So the radius of convergence is half that length, so 1/2. Now, to find a 6th-degree polynomial approximation of this series, we just need to list off terms until we hit a term that has an exponent of 6 on x. So what I'm going to do is I'm going to plug in values for k and list off the terms. Starting with k equals 0, I get 2 to the 2 times 0, x to the 2 times 0, which equals 2 to the 0, x to the 0, which equals 1. Then, for k equals 1, I get 2 to the 2 times 1, x to the 2 times 1, so 2 squared x squared, which is 4x squared. When k equals 2, we get 2 to the 2 times 2, x to the 2 times 2, so 2 to the 4th, x to the 4th, which is 16, x to the 4th. And then when k equals 3, 2 to the 2 times 3, x to the 2 times 3, so 2 to the 6th, x to the 6th, 64, x to the 6th. Now the series keeps going, but we just need a 6th-degree polynomial approximation. So since we've reached a 6th-degree term, we can stop, and this is our 6th-degree polynomial approximation.